Another unusual and unconventional repair. I've never done anything like this before. This time I was asked to restore a custom key for a Harley-Davidson motorcycle. As far as I understand, such blanks are not sold anywhere, and making a copy of this key is not so easy. The working part is very severely damaged, as if someone tried to open the wrong lock with this key. Also, judging by the traces of white solder, this key has already been repaired. Without going into too much detail regarding the so-called blades cut, I set about straightening the bent edges of the key using special tools, but I was hindered from properly straightening the geometry by the stub sticking out inside. To properly perform this task, I wanted to disassemble the key. However, it wasn't entirely clear what the blank was made of and what this black coating was. The solder connecting the parts, by its color and viscosity, looked a lot like tin. Since I had the opportunity, I decided to check it on a spectral analyzer just in case. As I suspected, it turned out to be a brass blank soldered with a tin lead solder. To disassemble this key, I just needed to heat it up to 300 degrees. After pre-treating the heating point with soldering acid, I carefully heated the key with a torch, constantly checking the temperature with a pyrometer. Having disassembled the key into parts, I waited for it to cool down and measured the inner diameter of the small barrel to select equipment for straightening the deformation. Now, not to complicate things, I decided to solder the entire cut with a laser. I took a brass wire and step by step, hole by hole, welded around the blank, trying to build up as much thickness as possible. Looking back now, I understand that it would have been much easier to make this small barrel anew because the buildup was not uniform everywhere, and the blank itself was porous in places. Therefore, I had to curl the surface into loops and overlay it again. After building up a fairly thick layer of metal, I hammered the blank on the mandrels to remove excess thickness and work harden the metal, giving it rigidity. Then I leveled the surface with a file, being careful not to grind off too much since the blank was already thinner than the original. Then I carefully sanded with different grit sandpapers inside and outside. I cleaned the soldering point on the key and at the same time polished the remaining surface to slightly freshen up its appearance. Now, to make the coated blade cut, I connect the small barrel of the blank with the original key using super glue. I let it dry and carefully, using a scribe, marked the width of the grooves. I already saw that the grooves were cut symmetrically there, so a mirror-like glue joint would not affect the copy's accuracy. Then, using a marking compass, I measured the depth of the grooves, and very carefully, to avoid mixing things up, I marked the groove depths on the blank. It was only when I reached a strange round hole on the workpiece that I realized the key was from another motorcycle because the slot fell right into this hole. The last thing I wanted at this stage was to solder everything again, but I had no choice. Most of the work was already done. I found a brass ball of a suitable size from my stock of alloys, slightly flattened it with flacings, hammered it on a metal mandrel, and soldered it with a laser from both sides. Such is Murphy's Law. In our profession, the slightest laziness can force you to redo the entire job. If I had checked the slot arrangement immediately, perhaps I would have done the repair quite differently. In short, I resanded everything and marked it. Then, for convenience, I painted the cutting layout with a red marker and went to cut the thread with a makeshift tool. My makeshift tool turned out to be a CNC wax milling machine, where I carefully and with a slight feed and lubrication in manual mode cut the grooves. Since I did not have a cutter of the right size, I had to cut the grooves in several passes. And since I was not sure about the accuracy of the manual feed, I decided to finish the keys cut under a microscope. To be sure the key fits, I heated the jeweler's kit paste for setting and made a mold of the original beard for fitting the copy. Then I adjusted the width and depth of the grooves manually with a regular cutter under the microscope until the new workpiece fit into the mold with the same effort as the original key. Well, the lower part seems to be ready. All that's left is to put everything back together. I covered the soldering point with flux, assembled the parts, pressed them tightly, and carefully heated them with a torch until the solder melted. Then I tidied up the item using minimal polishing to avoid thinning the already fragile brass workpiece. Finally, the traditional polishing and cleaning in an ultrasonic cleaner. Well, the key is ready, and I hope it will work and last a very long time. Otherwise, I don't really want to do it again.
Subscribe to the channel and watch the next part.